For part B of example 3, it reads, in a random sample of 15 households, what is the probability that at least 13 have cable? So the problem reads, what is the probability that at least 13 have cable? Well, what you need to understand out of this is that's the probability that x is greater than or equal to 13. Now, if you recall from the problem before, the problem earlier, n was 15. We have 15 households, and the given probability of success was 70%, leaving us with the probability of failure of 30%. Now, this problem is a little different because it'll be a cumulative problem. For a visual, if we just put 13 in the middle, if this were a histogram of any shape, n is 15. So in this situation, what we're looking for is to have the probability of at least 13. We would want the probability for 13 plus the probability for 14 plus the probability for 15. We can do this with the binomial formula, but in order to do that, we have to take the cumulative total for the probability of 13, the probability of 14, and the probability of 15. In other words, we have to do the binomial formula 3 separate times. We already have the answer for some of this, but it would basically, you would take for the probability of 13, we have a total of 15. We want 13, the given probability of success being 70% for the 13, and then the probability of failure being 30% for the remaining 2. Remember, there's a total of 15. We would take that and we'd add that to 14, and again, the given probability of success being 70%, probability of failure 30%, with just 1. Now notice how these exponents will always equal your total of n. 13 plus 2 being 15, 14 plus 1 also being 15, and then lastly we would do the combination for 15 and follow the same pattern. And that would give us our final probability for at least 13, which you should end up with almost rounded about 13%. Now in Minitab, what you need to realize is because this is a cumulative probability, we will need to use the CDF command. So in Minitab, we'll use the CDF command, but what we don't want to do is just put in CDF of 13, because for a visual for you, what CDF of 13 gives you is the following. CDF of 13 will take all of the probabilities, the probability of 13, the probability of 12, the probability of 11, the probability of 10, all the way down to the probability of 0, and it'll find the sum of all of these probabilities, and that's not what we want. In this case, if you recall, we were looking for the probability of x being greater than or equal to 13, which was the probability of 13 plus the probability of 14 plus the probability of 15. Minitab has a default to do less than. So this is where those storage spaces that you see in the notes come in. So rather what you'll do here is you'll put after your Minitab prompt CDF of 12, and you'll store that in K1. Now the reason you'll do that, I'll show you here. If this was 12, and again these are just random histogram bars. 11, 10, we'll do 14 and 15. We want to have these probabilities here. The sum of the probability for 13, 14, and 15. So because the default for Minitab, as I said, is less than, if Minitab figures out the probability of 12 and less, we can then just find the complement. So Minitab will take the cumulative, hence the CDF, probability of 12 plus the probability of 10, or sorry, plus the probability of 11, plus the probability of 10, etc., all the way down to the probability of 0. It will take that sum and store it in K1. The subcommand is the same as with all binomials. You enter bino for binomial. Our n was 15 and the probability of success was 70%. You do need the period. And then you have to tell Minitab what to do with what it's stored in K1. So what we're going to do is just tell it to let K2 be 1 minus K1, and then we're going to tell it to actually go ahead and print what's in K2. Now what that would look like is we're telling it to let this region here be K2, and what K2 is the entire probability to 0. So we're just going to take the whole thing, 1 minus K1, and you'll be left with K2, and you're left with your probability, which we said earlier was about 13%.